The earth, the animals, the plants, and the water, and the majestic mountains. There are only a few peaks in the world that rise 5 miles high, and all of them are here, in the Himalayas. Lethally cold, scoured by gales and blizzards. Ooh, that's cold. There's nothing better than the nice, refreshing taste of Dr. Pepper. These mountains are among the most hostile places on Earth, yet a few special animals manage to live there. Snow leopards. Like all creatures of the high mountains, they have had to adapt their body and their behavior in order to survive. This brings us to our question for today. Which size of paper rocket will launch the highest? And we will answer once and for all, does size really matter? Our first step in this journey was building the rockets. We knew to pull off something so cutting edge and so innovative, we need the two most prestigious scientists in the field. The two standouts, Dr. Estel and Dr. Gottberg, immediately agreed to participate in our experiments.
Hello, I am Mr. Dr. Isaac Estel. I studied rocket science and nuclear pathology at Harvard, and I currently teach aerospace engineering at Yale.
They first settled on the designs for each rocket, and then analyzed different possible materials to use.
We settled on military-grade microfiber printer paper as a substitute to the traditional construction paper to cut down on weight and increase efficiency.
After deciding that 3 rockets was the perfect number, Mr. Dr. Estel and Dr. Gottberg spent weeks testing and analyzing formulas to figure out what size to make these 3 rockets. They knew that calculations so advanced with so many variables would take nothing less than the most advanced supercomputer in the planet. After knowing exactly what size to make each rocket, the rest of the building process went as planned.
We first cut down the building material to the right measurement. We then formed and molded the material to the shape of the PVC pipe, then put on the fins and nose cone to complete the rocket. We were then ready to launch.
Our team conducted many tests, lasting many hours, and the results will shock you. We now go down to Emron, who's live at the launch site.
Alright, so here at the launch site.
Thanks, Emron.
T-minus 60 seconds and counting. Transferring to ultimate power at this time. Discovery is now running off its 3 on-board fuel cells. Coming up on a go for all sequence start. And we got a go for auto sequence start. Discovery's onboard computers are finally in control of all the vehicle's critical functions. Minus 17 seconds in. 15. 12. 11. 10. 9. 8. 7. That's it. Start. 2. 1.
I don't think that's right.
Seven, 6, 1. The largest rocket went an average of 32 feet. The medium rocket went an average of 38 feet. And the smallest rocket went an average of 69 feet. But what does this all mean? Why would the smaller one go significantly higher than all the others? Even though they were all shot at the same pressure and they were all the same weight. Maybe our experts can break it down for us.
To answer this mystery, we need look no further than the structural integrity of the rockets. The small rocket, aka the Choti, launched the highest in the sky. This occurred due to the amount of material per inch of rocket. Because all the rockets weigh the same, the smaller rocket is more dense and thus more structurally sound. It can also be reasonably assumed that the smallest rocket would encounter less air resistance because of its small and dense design.
Our scientists brought this experiment to a close, concluding that the smaller rocket had a denser design, which led to a more structurally sound and aerodynamic rocket that led to a higher launch. I'm Zach Homfire, and you're watching BBBC, Big Bahama Boys channel. And remember, ho's mad. Don't never stop sciencing.